All right, guys. To start off here, we're actually going to do a little bit of an activity. And that activity is going to require you to kind of take a look at your hand. And I want you to look down at your hand at this time. And I want you to take a look at your fingernails. And tell me if your fingernails are moving. Kind of interesting, right? Well, look closely. Are your fingernails moving? Or maybe a better question is, are your fingernails growing? Now, as you're sitting there looking at your fingers, you're probably saying, well, no, they're not moving. But I think we could prove that they're actually moving by not cutting our fingernails for the next 2 weeks, 3 weeks, month. If we wouldn't cut them, we would see that the tips of our fingernails would grow significantly. So then the question becomes, well, when do our fingernails grow? And the answer to that is always. Yes, your fingernails are continuously growing. And this gives us another application of Euler's number. You see, a lot of things in nature continuously grow. They don't just grow at a given time of the day or a given month of the year. They're continuously growing. And so with that, we can actually model some naturalistic growth using Euler's number. Let's go ahead and take a look at our first example. In our first example, what we're going to be doing is we're actually going to be talking about sharks. And to be more specific, this is actually modeling a tiger shark. So before we get going too much further, just realize the equation itself, this will be provided for you. All right. So with that, we see that the length L, now this is key, in centimeters of a tiger shark can be modeled by the equation that's provided. Keeping in mind that T represents the age in years, and again, L is the length in centimeters. Everything else is provided for us. Now the question itself says, what is the length at 3 years old? So, in order to do this, we're simply just going to take our equation and we're going to substitute in the value of 3 for T. Easy enough. Times 3. Now in order to do this, I'm going to go ahead and pull up my calculator. And so on my calculator, I'm going to go ahead and type 337 minus 276 e to the negative 0.178 times 3. Now note, in my calculator, it already puts everything up as the exponents. Some calculators do not do that, so you might have to incorporate parentheses in order to get the right value, which the right value ends up being 175.19 centimeters. So if I go back, I can then type in 175.19 centimeters. And again, units are key here. But let's dive a little bit more deeply into this question. And one of the things I want us to focus on here is with regards to the asymptote. What does the asymptote of 337 represent in this case? Now also keep in mind the asymptote is actually appearing before the exponential in this case. So it can be appearing after. Either way, it is the constant that's being added to the exponential, so that's what tells us it's the asymptote. But if we think about what's actually taking place in this problem, the asymptote actually represents the line that the graph approaches. So this means the length of the tiger shark approaches 337 centimeters. So to further take a look at some of this, let's go ahead and take a look at the graph itself. So all I'm going to do is I'm going to take the equation, I'm going to type it into my y equals. You'll note that just for consistency purposes, I put the asymptote at the end. It does not matter. It will still represent the asymptote. And if I hit graph, we have our following graph. And if you look at the y-axis, we can see that we're counting by hundreds, and the top actually represents 350. So we're approaching that 337 value, but never actually reaching it. Another quick thing I could actually show you is I could use the trace or the calculate feature to calculate a value. So if you take ourselves back, we were trying to figure out, what was the length of the shark after 3 years. So I type in 3, I hit enter, and I get that same value, 175.19. Now this was all well and good, but it sparked my interest about tiger sharks, so I wanted to see if this was actually accurate. So I went on to a website, National Geographic, and one of the things that we can see in this is you can see towards the top up here that it says the size is around 10 to 14 feet. All right, so now the only problem with this is our problem was dealing with centimeters, so I then had to convert, and by converting 337 centimeters, which was the asymptote, we could see that that is roughly around 11 feet in length. So in re-referencing the National Geographic, we see that 10 to 14 feet. So on average, the tiger shark does approach that asymptote of around 11 feet. So again, this is a modeling scenario. So this models the most appropriate length of the shark, but not necessarily all sharks. And another thing just to point out here is the fact that if you take a look at the graph, you could see how we grow very rapidly at the beginning. So in the first 5 years, we're growing really fast. And then the next 5 years, not growing as fast. And then after year 10, we've pretty much hit our maximum length. And I stopped